This video covers D3 map projections. The structure of this video is as follows: map projections, D3 geo projections, changing D3 geo projections, and the summary. Alright, let's get started. Map projections. In the last video, we created a map of the USA using a GeoJSON feature collection object. We passed this feature collection object into the GeoPath data generator. The GeoPath data generator then processed the feature collection and produced SVG path mini language instructions. This is a GeoJSON feature collection object. The features value for a feature collection object is an array of GeoJSON feature objects. There can be one or more GeoJSON feature objects inside the feature's value. This is a GeoJSON feature object. The geometry value for a feature object is a GeoJSON geometry object. This is a GeoJSON geometry object. The geometry object can be any one of these options. The coordinates are longitude and latitude coordinates. The longitude always comes first. Which brings us back to the USA feature collection object. What it really is a JavaScript object full of longitude and latitude pairs that are grouped in a certain way. By defining and grouping them in a certain way, we can later use them to create a map. We use the D3 GeoPath functionality to convert all of the longitude and latitude pairs into instructions for how to draw them on a Cartesian coordinate plane. We use the SVG x and y coordinates to draw the points in the SVG container, which, when we really get down to it, means that the D3 GeoPath function is a mapping function. In a figurative sense, it is a mapping function because it helps us draw maps on the screen. In a mathematical sense, it is a mapping function because it takes in a dataset and applies a function to each element of the list, thus returning a list of results. Just like we covered earlier, it takes in spherical coordinates, applies a function, and converts them to Cartesian coordinates. This is the map of the USA we created in the previous video. We took the GeoJSON feature collection object we obtained from GitHub and turned all of the longitude and latitude pairs into SVG mini language instructions. These instructions made a path all the way around the USA, and when it was done, it was filled with the color black. We have covered before that the D3 GeoPath function changes spherical coordinates to Cartesian coordinates. More specifically, D3 GeoPath does a mathematical transformation between geographic coordinates and plane coordinates. The type of function that does a mathematical transformation between spherical coordinates and Cartesian coordinates is called a map projection. The map projection is a flattening out of a map drawn on a 3D surface onto a 2D surface. Wikipedia has a list of 57 different projections. Some of the projections go back as far as the year 1569. Not only that, this list details just the ones that are considered the most significant ones. One way that projections can be classified is based on the type of projection surface onto which the sphere is conceptually projected on. The cylinder, cone, and plane can be thought of as map projections classified by surfaces. The more common way that map projections are classified is by how they preserve various properties on a map. The projections can either preserve direction, shape, actual area, distance between 2 points, or the shortest route between 2 points. These different requirements cause the shapes to be different from each type of map projection, so it is important to understand what you want to show when choosing a map projection to use. D3 Geo Projections. This is the map of the USA GeoJSON map we constructed in the previous video. You can see the whole of the USA in black. In the lower left-hand corner, you can see the state of Alaska and the state of Hawaii. As Alaska and Hawaii are not contiguous to the other 48 states, these two states are drawn floating in space just beneath it. This is an example of how a map projection can make decisions on where to draw things. Rather than drawing Alaska and Hawaii where they really are in relation to the rest of the USA, they are drawn where it is convenient and close enough to the map to fit inside of the projection. Let's first look at the size of Alaska versus the United States. Pay close attention to the relative sizes. Now, look at the actual size of the state of Alaska versus the 48 contiguous USA states. You can see that the area of Alaska is huge. Yet, on this map, it looks tiny compared to the rest of the USA. This is why it is important to think about and understand what you are trying to show when you are choosing a map projection to use. One more example. Look at this map of the United States. Hopefully you are familiar enough with your geography to know where Canada is in relation to this map. It should be above it and share the top border of the USA. Hopefully you are also familiar enough with your geography to know where Mexico is in relation to this map. It should be below it and share the bottom border of the USA. Keep these images in your mind. First, we get the GeoJSON feature collection objects for Mexico and Canada. Then we plot them on the map using the D3.geopath function. We use blue to plot the USA. We use red to plot Canada. We use green to plot Mexico. Do you notice anything strange? You should notice that a huge part of Canada is missing. You should also notice that a huge part of Mexico is missing. You should also notice that Alaska now has a border with Canada that is being displayed. You should also notice that the Hawaiian Islands now appear to be located inside of the country of Mexico. What happened and why did this happen? The reason this happened is because the default map projection that D3.geopath uses is the D3.geo Albers USA projection. Because we did not specify what projection to use, D3 used the default one, which is made for the United States. So when we added two other countries that contain longitudes and latitudes not present in the United States, things went wrong. This is the Albers USA projection from the D3 wiki for geoprojections. This projection takes in longitude and latitude points and places them on this map. So if we have the longitude and latitude for a city in the state of Hawaii, it will place the object on Hawaii. If we have the longitude and latitude for a city in the state of Alaska, it will place the object on Alaska. The same goes for the rest of the 48 United States. This is very useful if you are mapping objects onto the map of the United States. If you are not mapping objects in the United States, then you will have to use a different projection. If you wanted to show something in the rest of the world, you could use the Mercator projection. This type of projection is one based on projecting a sphere onto a cylinder. In this projection, you can see Canada, Mexico, and most of the rest of the world. It is missing the actual north and south poles as well as the lands near the poles. For most mapping that you will want to do, this projection will let you map it. Another way to show the whole world is to use the orthographic projection. This type of projection is azimuthal, which is one that preserves direction. With this type of projection, you can show a single hemisphere of the world. This is a projection that most of your audience will be familiar with from looking at a globe. As you can imagine, this type of projection lends itself to rotation and animation that looks amazing. These are the 13 basic standard projections that D3 comes with out of the box. Each one has a specific reason for being used and a specific view of the world. As we covered before, some are projections on cones, some on planes, and some on cylinders. Others preserve area, or preserve distance, or preserve direction. It is up to you to gauge the goals of your visualization to choose which kind of projection you would like. Note, as if 13 weren't enough, the Extended Geographic Projections D3 plugin and the Polyhedra Projection D3 plugin give you vast quantities of more types of projections you can use. They are definitely worth taking a look. We will cover all of these 13 projections in the next section and see how they actually look on a map. Note, we will not show the mnemonic projection due to the fact that more advanced techniques are required to work with that one. Alright, so now that we know that we have access to these projections, how do we go about changing the D3.geopath default from D3.geo Albers USA to another projection? Changing D3.geo projections. D3.geopath is a path data generator function that has a default setting of Albers USA projection. It takes in a GeoJSON object and returns SVG path mini language instructions. In order to set a specific projection type, we can use the projection method. If a projection is specified, then it sets the projection to be used by the path generator. If a projection is not specified, then it uses the current projection. If no current projection has been specified, then it uses the default projection. At the beginning of this video and the last video, we covered how to create a map of the USA using a GeoJSON feature collection object. We passed this feature collection object into the GeoPath data generator. The GeoPath data generator then processed the feature collection and produced SVG path mini-language instructions. If we wanted to specify the default ourselves, this is how we would do it. We would pass the D3.js projection to the projection method in order to set the projection for the D3.js path. It is by setting the projection that we are specifying the projection function that will do a mathematical transformation between spherical coordinates to Cartesian coordinates. So we can pass in any type of GeoJSON object that contains longitude and latitude pairs, and we will get back SVG instructions related to Cartesian SVG coordinate plane X and Y pairs. Because D3.js is a function, we can easily rewrite the projection that it is using and then create a new path using the new projection. As you can imagine, the projection method itself has several ways that we can tweak and define its behavior to better suit our needs. Each of these types of projection modifications will alter the function that converts spherical coordinates to Cartesian coordinates. Some of these modifications require some mathematical understanding of spherical coordinates, while others are more straightforward. We will leave these for another time. What we will take a look at, since this video is about D3 map projections, is 12 of the 13 kinds of projections on a web page. This will help us understand visually just how different all of the projections can be. For continuity's sake, we will continue to use the USA, Mexico, and Canada maps. This webpage has the D3 library imported from the D3.js.org website. The D3 code has been written into an index.html file. We are running this page using Python Simple HTTP Server. Python Simple HTTP Server is a very basic web server that you can run if you have the Python programming language installed. You can go into the folder that you want and type python-m simple HTTP server. It will then serve the files from that folder. It serves up any file in the folder with any given extension, which means that we can do an AJAX XHR D3 type specific call to the server and it will serve the file type we ask for. In this case, we will be requesting 3 JSON files and reading them in with the D3.json XHR functionality. Alright, this is the same example as before, with the only thing that has changed is the width of the SVG viewport. The initial drawing is using the default projection of D3.js, which is D3.js USA. Next, let's take a look at D3.js projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We see all of Mexico and all of Canada. Also notice that the island of Hawaii is now somewhere in the Pacific Ocean. Also notice that Alaska is now connected to the top left of Canada where it should be. Alaska is now also bigger than before, while Hawaii is a bit smaller than before. Next, let's take a look at D3.js azimuthal equal area. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. However, the shapes are now distorted. In fact, they look like they are lying on a globe that has been projected onto a two-dimensional surface. Notice that the Hawaiian Islands now look almost as long as the entire west coast of the USA. Next, let's take a look at the D3.js azimuthal equidistant projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. However, the shapes are now distorted. Even though this is an azimuthal projection just like the last one, this one looks a bit different. It is still looking like it is lying on a globe, it just has a different shape. Next, let's take a look at the D3.js conic conformal projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This time the shapes look less distorted to how we are used to seeing a map, except that it is slightly tilted. Next, let's take a look at the D3.js conic equal area projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This is a conic projection just like the previous one, only this one emphasizes equal area. You can see that this projection makes it feel like the countries have been squished from their left and right sides. They don't appear as elongated as you usually expect. Next, let's take a look at the D3 conic equidistant projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This is a conic projection just like the previous one, only this one emphasizes equal distance between points. This looks closer to what we are used to seeing, though not quite there. Next, let's take a look at the D3 equirectangular projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This projection divides the globe into equal rectangles and then projects the entire map onto a 2D surface. This is why Canada looks stretched out, because as we go north, the spherical coordinates will have different lengths at the bottom than the top of the individual sections. So when we stretch out the top to make the rectangle have an equal top and bottom length, the top side will get stretched out. Next, let's take a look at the D3 Mercator projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. The spherical Mercator is the projection commonly used by tiled mapping libraries. OpenLayers and Leaflet.js use it. This is the most common projection that we would be familiar with. In this projection, you get a different feel for just how much bigger Canada and Alaska are compared to the mainland USA and the country of Mexico. Though again, this map is slightly distorted, so you cannot make a full judgment call. Next, let's take a look at the D3 orthographic projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can almost see all of Mexico, all of Canada, and all of the USA. This is an azimuthal projection that is used to display a single hemisphere. Note that the island of Hawaii is closest to us. This is a projection and example where to really get the most out of it, we would have to go into the projection to tweak exactly what it was showing and how. Zooming and panning do not help us see this projection clearly. Next, let's take a look at the D3 stereographic projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This is another type of azimuthal projection that is used to display a single hemisphere. This projection is commonly used for celestial charts. One interesting side effect of this projection is what it does to the island of Hawaii. It makes the island of Hawaii look enormous. Next, let's take a look at the D3 geotransverse Mercator projection. After we zoom and pan the figure to be in the center of our screen, we can see the full picture. We can see all of Mexico, all of Canada, and all of the USA. This is another type of Mercator projection. This projection is meant to be used for small areas like cities and regions. One interesting side effect of this projection is what it does to the island of Hawaii. It makes the island of Hawaii look tiny. Again, this is because this projection is meant for small areas, so it really distorts large areas. And with that, we have covered what map projections are and how they work. We then covered D3 geoprojections and how we can use them. Then we covered how to change D3 geoprojections according to what and how we want to project our spherical coordinates. Lastly, in this section, we went through 12 of the 13 D3 standard projections to get a feel for how they look with the maps of Mexico, Canada, and the United States. The summary. This video covered map projections, D3 geoprojections, changing D3 geoprojections, and the summary.